Problems 8 through 14 are true or false questions. It looks like I've marked out some words here, but that's really just highlighting some words that you need to pay attention to. On this video, I'm just going to focus on numbers 8 through 10, and I just want to remind you that if you'll look on the note sheet for Unit 4 Worksheet 10, that's the true-false sheet, and it'll have a whole lot more examples on there that you can look at if you have forgotten how to do these. On number 8, it says, if the radius of a cylinder is doubled, then the volume is quadrupled. So you need to be looking at what formula you're going to be using to answer this question. And it's a volume formula, and it's for a cylinder. So the formula we'll use is the volume for a cylinder, which is pi r squared h. So you'll really need to know your formulas for this part. We are doubling the radius. So for my second volume, I'm going to replace the radius that is squared with a 2r instead of just an r. So 2r squared, remember, means 2r times itself, 2r. 2r times 2r is 4r squared. So this becomes pi times 4r squared times height, and in order to compare it to my original formula, all of this is multiplication, so the order doesn't matter. I'm just going to put that 4 in front and then the pi r squared h. So I can see my original volume of pi r squared h was quadrupled. So this statement is true. When I doubled the radius, my volume quadrupled. So number 8 is true. Number 9 says, if the length of a rectangular prism is tripled, then the volume is tripled. So what formula are we looking at? It's a volume formula for a rectangular prism. So the formula for a volume of a rectangular prism is length times width times height is equal to the volume. So for my second volume, I'm going to triple the length. So I'm going to replace the L with a 3L. So instead of L times W times H, I'm going to have 3L times W times H. Well, I can already see the effect. Here's my original volume. Here it is here, and it has been tripled. So this question is also a true question, that when I triple the length, it triples the entire volume. On number 10, it says if the length of each edge of a cube is halved, then the surface area is halved. So we're looking at the surface area of a cube. Now be careful here. You don't want to use s cubed here. That's the volume of a cube. So the volume of a cube is length times width times height, where they're all side lengths that are the same. So it's s cubed. This one's talking about surface area. So with a cube, you have 6 faces that are all squares. So if you find the area of a square, one square is s squared, and you have 6 of them. So the surface area of a square is 6s squared. So I am having the length, so my s is going to be replaced with a 1/2 s. Okay, so I have 6 times 1/2 s squared. Well, the 1/2 s is being squared, so remember that's 1/2 s times 1/2 s. 1/2 times 1/2 is 1/4, and s times s is s squared. So to compare it to my original surface area, which is 6s squared, I'm going to move the 1/4 in front. So I can see I have 1/4 of that 6s squared. So now I can compare them. My original surface area has been cut into 1/4, not halved. So this is a false statement. If you want to go back and look and see if these create similar solids or not, you can use our rule of, if you know the linear ratio is m over n, then the surface area is m squared over n squared, and the volume is m cubed over n cubed. You can't use that on number 8, because if you only double the radius, you're not creating a similar solid. You'd have to double both the radius and the height. So you can't use that on number 8. You cannot use it on number 9 either. If you wanted to use that rule, you'd have to do the same effect on all 3 dimensions. Since you're only tripling the length, you can't use this rule. The only one you could use it on is number 10. Since a cube only has 1 dimension, if you half it and you want to see its effect, that's the ratio of the linear measurement, its effect on the surface area, just square it. So 1/2 squared gives me 1/4. So that would tell me that the surface area is cut in 1/4 without even using the formula for the surface area of a cube.